One of the first remarkable stories that I heard about Tesla happened back in probably 2011, before they even built the Model S. I'm telling the story off the top of my head because I can't find the source material anymore. But more or less, Tesla needed to buy this huge machine. It was called a Schuler press. I don't even know how much it weighed, multiple, like hundreds of tons, and it was 5 stories high. This Schuler press cost $50 million to buy new. Tesla didn't have that type of money back then, so luckily they were able to find this gigantic machine in Detroit from a auto manufacturing plant that closed down. It's probably GM, not sure, but anyway, before they purchased the press, they asked the manufacturer, Schuler, hey, how much would this cost to ship, for you guys to take it apart, ship it, and then reassemble it at Tesla? And Schuler came back and they said it would cost $35 million to do that. So obviously that wasn't going to work. But Tesla went ahead and purchased the press. And Elon Musk asked his engineers, can you guys come up with a solution to ship this machine from Detroit to Fremont for less than $35 million? So the Tesla engineers somehow came up with a way to cut the Schuler press in whatever way that they could, so the pieces to be able to fit into train tunnels. And they were able to ship this gigantic machine from Detroit to Fremont via the train tunnels, and it only cost them $2 million. So they were able to get this $50 million machine for $6 million, including shipping. When I heard this story, I was pretty blown away on how Tesla was able to come up with this solution while the manufacturer wasn't. To me, this story perfectly represents how Tesla is not willing to accept information that's given to them as absolute truths. They are able to think out of the box, and this attitude allows them to be very innovative. And because of this attitude, they will always have a competitive advantage. So what I want to do in this video is show how this attitude of not taking information for face value pops up over and over again. And I want to do this by showing the innovations that Tesla has come up with over the years. I have 8 innovations prepared for this video, and we're going to start with number 8. The Model X Falcon Wing doors.
The car actually automatically senses what the roof height is. So there are ultrasonic sensors in the roof of the car that calculate the roof height and automatically compute a new opening arc depending upon what the height of the ceiling is and what the side obstacles are. And we actually developed a new ultrasonic sensor that's able to do sonar through metal. So in order to avoid having a puck, which is ordinarily needed for ultrasonic sensors, we thought the aesthetics of the puck would not be good because it would have to be in the center of the door. So we actually developed an ultrasonic sensor that can literally see through metal.
They created a new type of sensor that uses sonar to see through metal. Like, seriously? Like, what other type of car manufacturer can do that? Only Tesla. If they could do something like this, then they could pretty much make any part that they want to. If some part doesn't exist in the marketplace, they can just make it themselves. Or if they have a supplier and they're not happy with the quality of the goods that they're receiving from that supplier, they can just fire that supplier and make that item themselves. Man, I'm surprised Omelette hasn't come yet. Be right back. There we go. Number 7, the Model 3 General Assembly Plant. All right, so a bit of background on this one. Back in 2018, when Tesla was ramping up their production of the Model 3, they were having production problems that were not meeting expectations. And part of the reason for that is because they had over-automated some parts of their production line, especially in General Assembly. So General Assembly is the final stage in which a car is built. It's where all the finishing parts and details go into a car. Like, that's where they put in the windshield, the wheels, the seats, the handles, things like that. So to solve their general assembly problems, they created a new general assembly line in their parking lot, and they refer to it as GA4. I'm going to play an excerpt from an earnings call in Q2 2018 where Elon Musk and another executive, Jerome Guillen, talks about GA4.
We just wanted to create an assembly line that would be very easy and very straightforward. So it's a straight line. Very simple. Car enters at one point and is finished at the other end. Very simple access on all sides. Very simple tooling that we reused for most of, actually nearly all of it is systems and tools that we discarded from previous SNX or for Model 3.
Especially Model 3. I mean, the problem is we had 2 weeks to solve this problem, which is like quasi impossible. Yeah. So we actually didn't have time to order new equipment because it would have taken too long to arrive. So we took the conveyors that we'd discarded from the GA3 line, which didn't work, or was way too complex to actually deliver parts.
And we simplified, repurposed them, make them sturdy for what was needed. And
well, I thought like a really cool idea was putting them on the 1% grade. Yeah. So it's like technically the conveyors for parts delivery to GA3 were not rated to be able to move something as heavy as a car. So we made it downhill and on a 1% downward grade, put the car at the top, so then you can actually overcome the transport.
Gravity helps.
Yeah, gravity. Exactly. Basically, with Newton on your side, you can accomplish a lot.
Yeah, it's pushing the car. Yeah.
Exactly.
So this is a very pleasant surprise, and the associate seems to be very happy and engaged in that particular area. So this may be a model of how we may want to start general assembly for future vehicles. At least start, and we can always add further automation and complexity.
Something that's like somewhat counterintuitive is that this actually has fully considered fewer labor hours per car than the GA3 system. And just to elaborate on what Jerome was saying, when we have parts delivery to GA4, the truck literally just backs up to the side of the line where there's like a door in the tent, and then that is used to unload parts from suppliers directly to where they're needed on the line. So there's no intermediate system. Whereas for GA3, they're unloaded, they're put in a warehouse, then they're repackaged from the warehouse into these totes, so we actually had 220 people, something like that, across all shifts. But whose only job it was to repackage parts from the boxes that came in suppliers to these totes that go into the lifters that go up into GA3. That's literally all they do is move things from one box to another box, and we don't need that at all on GA4.
All gone.
All gone, yeah.
GA4, or General Assembly 4, is another creative solution to solve a complex problem. And their idea of using a 1% grade so that their conveyor belts would work properly, it's like, what? Seriously? Additionally, the lessons that they learned from constructing GA4 went on to influence the factory design of Shanghai, Berlin, and Texas. Number 6, the Model 3 SuperBottle. The Model 3 SuperBottle is this plastic bottle with a couple of valves and pumps, and it's basically responsible for the heating and cooling of the entire Model 3, the early versions of the Model 3. The SuperBottle has since been replaced in the Model 3 with basically a SuperBottle 2.0. We'll talk about that later. But I want to talk about the SuperBottle 1.0 because when I first heard about this invention by Tesla, it was the first time I started to realize that the auto manufacturers, the legacy auto manufacturers, are really screwed.
The SuperBottle is a great example of how the normal automotive companies don't work together, and Tesla does. So that SuperBottle crosses many lines that you can't cross here. I mean, if I'm in charge of engine cooling or battery cooling, I don't want I want nothing to do with cooling the cabin and yet we've got the motor cooling, the battery cooling,
and
electronics, and the and all going through one little bottle that's got some clever little ball valves that open and close to make sure that everything's getting heated or everything's being cooled to where it needs to be. That's really, I mean, so I'm taking something that I would have a pile like this of bits and pieces, and they've got this SuperBottle. That's, I mean, we all thought that was the best thing in the whole damn car.
That was Sandy Monroe. If you follow Tesla, then you know who Sandy Monroe is. But if you don't, make sure to check him out. Him and his company, the people who work for him, are industry experts in the auto industry when it comes to manufacturing and design. His company created this diagram that compares the Model 3 cooling and heating system to the Chevy Bolt. To the left is Tesla's cooling and heating system, which is just that one diagram, and then the next 3 diagrams show the Bolt's 3 individual cooling systems. It means they need to make 3 times the number of pumps, 3 times the number of bottles, and a bunch of other things to make the system work. Tesla has just one system that is holistically designed to control everything. Not only that, since their system has less parts overall, the system is easier to install, cheaper to make, weighs less, and takes up less room. Number 5, the Model Y Octovalve. The Model Y Octovalve is basically the SuperBottle 2.0. It was first introduced into the Model Y, but now it is also in Model 3.
I'm very, very impressed with the Octopump and the Octovalve and the heat pump, and that's a shining example of a non-automotive design. If you compare it to different vehicles, you'll see that the other guys are using, a separate radiator, or they're doing they PTC heaters or something like that. Something that's easy. You just buy this and you buy that and you glue it together and call it a day. This stepper motor will move and shift depending on what load or what action the coolant system is calling for. The little valve here is like genius. I really wish that more people would take a look at how to take a whole bunch of functions and turn it into one.
Number 4, the Giga Press. The Giga Press is this huge machine that produces the rear body frame of the Model Y, and it will eventually be used to produce the front body frame too, as well as all future front and rear body frames for Tesla.
It starts with having a single piece casting, or a single piece casting for the front body and the rear body. In order to do this, we commissioned the largest casting machine that has ever been made, and it's currently working just over the road at our Fremont plant. We have it's pretty sweet. Currently making the entire rear section of the car as a single piece, high pressure die cast aluminum. And in order to do this, we actually had to develop our own alloy. Because we wanted a high-strength casting alloy that did not require coatings or heat treatment.
The Giga Press is not made by Tesla, it's made by a company called Idra, but even though Tesla didn't invent that technology, they are the first and only company to be using this large Giga Press. And it's not like these Giga Presses are easily bought off the shelf. If another auto manufacturer wanted to buy one, they would have to go through the sales process and the installation process, and that would probably take over a year. They also have to wait in line because Tesla just bought like 11 of these. And then on top of that, they have to design and engineer their casting in order for it to perform consistently in a crash test. And then Tesla had to invent like an alloy so that the casting would cool properly without deforming. So basically, in other words, Tesla is probably at least 3 years ahead of the competition when it comes to using this type of manufacturing. Number 3, Tesla's full self-driving chip. Tesla's full self-driving chip is a chip that is purposely built for full self-driving applications using large neural networks. There's a bunch of reasons why this chip is so significant, but I'm obviously not the right person to explain it. But the gist of it, as I understand it, is that Tesla has this approach that is different from everyone else when it comes to full self-driving. They rely on vision only, meaning cameras, and they also heavily rely on artificial intelligence. So they have this chip that is laser focused on being able to process large neural networks. Third-party chip makers like NVIDIA, AMD, and Intel don't have these chips that are purposely built for what Tesla is trying to do. So Tesla had to basically go out and make a chip of their own. These third-party chip makers specialize in creating GPUs, graphic processing units, and these GPUs are just not efficient at doing what Tesla wants to do. James Doma, who is a neural net expert, gives a much more in-depth explanation where he explains the difference between Tesla's chips and a competitor's chip, the NVIDIA Drive AGX.
So you're going to get a solution which is, at minimum, several times what Tesla's costs. At minimum, uses several times as much power as Tesla's solution. and is effectively slower for the one thing that Tesla wants to do.
Number 2, the Cybertruck design. The Cybertruck design is another example of something that can only be created at Tesla. Can you imagine another manufacturer creating that type of design? If that design ended up flopping in the marketplace, whoever was responsible for the design would probably be banned from working from the auto industry again. But not at Tesla, because the people who work at Tesla are fearless.
This is a 30X. The X means that they're not telling you what that last ingredient is in the cold rolled stainless steel that they're going to be using. This is going to be something that's going to be ultra hard. It's probably going to resist corrosion significantly, and also make it so that they can develop the product with simple stamping methods. There's a lot of advantages. And again, the biggest one, no paint job. When you're trying to start up a car or a vehicle of any kind, you have to look at whether or not you're ever going to get your money back. Your investment costs are the things that you have to think about. And with this product here, it's going to start off with simple tooling. And then on top of it, it doesn't have to have a $500 million paint job.
So the Cybertruck design makes it so that the Cybertruck doesn't need a paint job. And not needing a paint job means that the Cybertruck can be produced cheaper and faster. Additionally, not needing a paint job saves room on the factory floor, and that room on the factory floor can be used for something else. And then number 1, which is basically 5 things in one, but number 1 is everything shown on Battery Day. Battery Day was a barrage of innovations all at once. It was a 2-hour event, and I'm just going to show you some highlights of Battery Day that would basically summarize the whole 2-hour event into 5 minutes.
And this is what we mean when we talk about tablets. It's kind of a beautiful thing. We basically took the existing foils, laser patterned them, and enabled dozens of connections into the active material through this shingled spiral you can see. With simpler manufacturing, fewer parts.
It's insanely difficult to scale up.
But if you do scale it up, what you saw before becomes this.
This is what we're trying to do here is say, okay, how do we, with one factory, achieve what maybe 5 or even 10 factories would normally be required to achieve? Basically, Tesla is aiming to be the best at manufacturing of any company on Earth. This is the thing that's actually most important in the long run. Eventually, every car company will have long-range electric cars. Eventually every company will have autonomy, I think, but not every company will be great at manufacturing. Tesla will be absolutely head and shoulders above anyone else in manufacturing. That is our goal.
Here's a view of the traditional cathode process. Effectively, if you start at the left and you have the metal from the mine, the first thing that happens is the metal from the mine is changed into an intermediate thing called a metal sulfate, because that's just happened to be what chemists wanted a long time ago.
It's insanely complicated. If you look at the total, like if you're just like, it's a small world journey of I am a nickel atom, what happens to me? And it's crazy. Like you're going around the world 3 times. It's total madness, basically. And these things just grew up as they're just kind of like legacy things that it's like how it was done before. And then they connected the dots, but really didn't think of the whole thing from like a first principle standpoint, saying how do we get from the nickel ore in the ground to the finished nickel product for a battery. And so we've looked at the entire value chain and said, how can we make this as simple as possible?
We get rid of the intermediate, metal, water, final product cathode, recirculate the water, no wastewater at all.
In the early days of aircraft, they would carry the fuel tanks as cargo. Then somebody said, hey, what if we just make the fuel tank in wing shape? So all modern airplanes, your wing is just a fuel tank in wing shape. This is absolutely the way to do it. And then the fuel tank serves as dual structure, and it's no longer cargo. It's fundamental to the structure of the aircraft. This was a major breakthrough. We're doing the same for cars. It also allows us to pack the cells more densely because we do not have intermediate structure in the battery pack. So instead of having these like supports and stabilizers and stringers and structural elements in the battery, we now have a lot more space in the battery because the pack itself is structural.
In addition to the improvements we just said on enabling additional range and improving the structural performance of the vehicle, it is worth another 7% dollar per kilowatt hour reduction at the battery pack level, bringing our total reductions now to 56% dollars per kilowatt hour.
Yeah. To be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages, probably it's about 3 years or thereabouts.
Hopefully after watching this video, you can see that the level of innovation at Tesla is just insane. It's unmatched compared to any competitor. And it's not like these innovations just happen once in a while. They happen year after year after year. Anyways, all the videos that I reference are linked in the description below. So if you want to learn more about any individual topic, then take a look at those videos. Thanks for watching. I will see you in the next video.